and it's a closed surface होता है.
Okay.
But
Yeah. Okay. See, a control volume is a fixed volume in space. So we are not going to uh, track individual particles and then determine the property of the particles, but rather we will fix this particular surface, and whatever is the fluid that is coming into this surface, we will analyze that. So we will analyze what is coming in, what is going out, but we will not follow this particular fluid. We will only be concerned about this particular what is happening inside this particular space. So a control volume is just a frame of reference or a volume in space through which a fluid or any matter can pass, and this control volume does not have any defined shape. It can be of any shape depending on the problem, and the boundary of the control volume is called as the control surface. So we will be interested to know what is happening at this at the along the control surface. So whether any other fluid particle is coming from this side or this side, we'll be taking into account whatever is coming through the surface. And this control volume can also deform with time, and it can also rotate in space. So this kind of problems you'll be seeing in your fluid mechanics. But as far as hydrology is concerned, mostly it will be of fixed control volume, and the mass in the control volume changes with time. So some amount of fluid is coming, and initially there will be some amount of mass. After a certain time, it will change. And this is another kind of problem. This is a kind of pressure pipe flow. You have a control volume in this particular shape. Okay. So next is related to the Reynolds transport theorem. So what does Reynolds transport theorem represent? So what are we doing in the Reynolds transport theorem? What is your LHS and what does your RHS represent? Can anyone tell?
sir, hello.
Yeah, you are audible.
Sir, in a Langani approach, we can focus on motion of the body,
Yeah.
and in Euler's approach, if focus in control volume as a fixed frame.
Yeah. Okay. Now, what does Reynolds transport theorem represent? So, what is the term on your LHS of your Reynolds transport theorem? It is dB by dt.
DT.
So what does that represent? Which approach it is?
Sir,
So is it Lagrangian approach or Eulerian approach?
sir, I think Lagrange.
Yes, it is Lagrangian. So because here we are tracking the change in the property of the fluid with respect to time,
Yes, sir.
and that is the it represents the system property. And on the right hand side, we are fixing some control volume, and then we are happening what is happening within that control volume. So your term 1 and term 2 represents the integral over your control volume, that is the rate of change of the properties that happens within the control volume plus the rate of change that is happening at the control surfaces. So that is your Lagrangian and your Euler's approach. And Reynolds transport theorem is a platform which relates the Lagrangian and the Eulerian approach. So your week 1, your major numericals is only the residence time and some theoretical background. And in week 2, there are some theory questions. So the first question is, dash is an interface between warm air mass and the cold air mass. So when two distinct air masses with a warm temperature and a cold temperature meets, a front is formed. And we have different types of front. One is the cold front and another one is the warm front. So in your cold front, what happens is you will have your cold air and your warm air. But in this case, your cold air will advance through the warm air. As a result, your warm air will rise up, and then as the warm air rises up, it condenses and it produces the precipitation. So let me just play a small video. So you can see this, no? So your cold air is moving and your warm air is rising. Your clouds are getting formed and it produces the rainfall. So this is called as the cold front. And this particular characteristic has a slope of 1:100, which means for every 1 kilometer rise of the warm air, the horizontal distance will be approximately 100 kilometer distance on the ground. So which means that your precipitation is concentrated in a very small area, but the amount of precipitation it produces is huge. So if you see this question, dash causes less intense but widespread precipitation. So previously we saw the cold front, but here it is, but the less intense rainfall and widespread precipitation, which is produced by the warm front. So again, I'll play one more video for this warm front, so you'll understand what is happening. So you can see here, right? Your cold air remains still, but the warm air starts rising because of the density difference. Cold air is heavier than your warm air, and as it rises, it starts condensing and it forms the clouds, and then it rains. But if you see the kind of slope it has a very flat slope, and it extends for a large area. So the properties of the warm air is 1:200. So for every 1 kilometer rise, it will be spread over a distance of 200 kilometer on the ground. It has a widespread rainfall, but it will not produce a very intense rainfall. Understood?
Yes, sir.
Okay. So next question is related to the cloud condensation. So your cloud, for condensation to happen, there is the requirement of a seed, which is called as a condensation nucleus. So around which the water molecules can attach and then grow in bigger size, and then basically it forms as a precipitation. So your condensation nuclei is a particle impurity basically. So it can be of dust, ions, or any kind of impurity. We can also term them as aerosols. And your water vapor is attracted to this particular cloud condensation nuclei, and it forms bonding with that particular cloud condensation nuclei through the hydrogen bonds. So this particular cloud condensation nuclei serves as a substrate on which the droplets can grow. So only when such kind of nuclei is present, your condensation can happen and it forms into a larger cloud droplet. Okay, I'll be sharing some of the numericals now. So is my screen visible?
Yes.